Hello everyone, welcome back. In this session, we're gonna take a look at the load balancing methods, load balancing algorithms. We're gonna see the different options that we can configure as a load balancing method, and we're gonna test them in our lab as well. So let's start. The first group of load balancing algorithms or methods called static load balancing. Static means it's deterministic, so the behavior is predefined. So for example, round robin. Round robin, we have seen round robin is user 1 to server 1, 2 to server 2, user 3 to server 3, user 4 back to server 1, so one by one, even distribution. So it's deterministic for us. Nothing will change over time. It's stateless. It does not look at the server status. Maybe server 3 is experiencing problem with the CPU, is being very slow to respond to users. The users who are hitting server 3, the application is very slow. It doesn't matter. The LTM, when you configure round robin, it's stateless. It does not look or monitor the server performance metrics. For the LTM, it's round robin, one by one. That's it. So it's a static. Ratio, the ratio load balancing is configurable value. So you give each server a ratio. Maybe you can say percentage, how much you want this server to handle out of the overall. So if you expect, for example, for the sake of the example, if you expect 500 users to be accessing the application and you have 3 servers, so how do you want to distribute the 500 connection or 500 users over the 3 servers? Now, in a normal scenario, you want them kind of equal, but let's take this scenario. Let me just go to the whiteboard. So if we have server 1 8 gig RAM, 1 CPU. Then we have server 2, 16 gig RAM and 2 CPU sockets. And server 3 the same, 16 and 2 CPUs. Now, looking at the hardware resources available for each server, I expect that we need to configure server 2 and 3 to handle 2 times the amount of users that server 1 can handle. So if we have 500 users or connections, I can say I want server 3 to take 200, server 2 to take 200, server 1 to take 100. So I came up with a percentage based on the hardware resources that each server has. So usually it's the application team who tell us each server how many users or connections they can handle. But in this example, we use the hardware resources available to kind of give a ratio to each server. So the configurable ratio, now what we can configure on the pool, because we have 3 servers in a pool, and instead of round robin, we will configure our load balancing method to be ratio. So we tell the pool that when you get a request, look at the ratio. So let's simplify the ratio. This is 1, this is 2, this is 2. So user 1, come. This. So user 1, go here. User 2, go here. User 3, go here. Now user 4, go to 2. User 5, go to 3. User 6, go back to 1. User 7, 2. User 8, 3. User 9, 2. User 10, 3. And so on and so forth. So the LTM should always try to send double number of connections to server 2 and 3. We send one connection to server 1, then 2 to 2, 3, and 2 to 3 to server 3. This is how the ratio load balancing method works. So it is us, we configure the ratio per node. Let's test that. Let's test it. So the virtual server is fine. The pool is up. Before we change, let's just make sure that things are still working in our lab. Yeah. So the load balancing is working just fine. So let's go to the pool. Go to members, and we change it from go to members. Previously it was round robin. Now we want to make it ratio update. So we changed the load balancing method. Now we have to change the ratio for each pool member. The default is 111, so equal. We said for server 1, let's keep it 1. Let's take server 2 and give him 20. And let's take server 3 and give him, you know what, let's give a 5. Let's keep the number low, better, so that we can test. So we give 5 to, so 155. So we change the load balancing method, click update, then per node you change the ratio. Let's go to statistics. Let's reset all statistics, make it 0. So let's test here. So 1, 2. So we landed on server 2, 2, 3, 2. So we will keep going between 2 and 3. Then rarely we should go on 1. Technically we should go 5 times to 2, 5 times to 3, then 1 time to 1. So refresh, keep refreshing, Control F5. So we're going more on 2 and 3. So if we go to statistics, we can see that 10 to 50, which is almost 1 to 5. So this is how the ratio based work. It all depends on the ratio that we configure per member. Now, as you can see, there is ratio member and there is ratio node. It's ratio member and ratio node. Reason why? Because here we used ratio member because we configured the ratio based on the pool member. This is a pool member. The other place I can configure a ratio is on node. If I go to node, I can still specify a ratio per node. If you choose to specify the ratio on the node level, then your load balancing method should be ratio node. If you choose to define the ratio on the pool member level, then definitely you have to go with ratio member or pool member. Now, what's the difference? When do we use this? When do we use this? Let me go back to the whiteboard. Now let's test the ratio node. Here on the pool level, it's 155. Let's increase it. Let's make it 110. 10. So on the pool level, let's document this. On the pool level, node 1, node 2, node 3. Ratio 1, ratio 10, ratio 10. This is on the pool level, 1, 10, 10. Now, on the node level, I'm going to say node 1 ratio 10, node 2 ratio 1, node 3 ratio 1. Complete opposite. So, and let's see which one will take effect based on our load balancing algorithm. So this is 11010. Let's go to the node, click on node 1, make it 10, update. Click on node 2, it's already 1. Click on node 3, it's already 1. So now we have the following scenario configured. In pool 1, we have 1, 10, 10 as a pool member. On the node level, we have 10, 1, 1. Now, if we go to the pool, at the moment, our load balancing algorithm is ratio member. So we should expect this ratio to take effect. 1 to server 1, 10 to server 2, 10 to server 3. Let's test. So we hit server 2. We should see server 2 and 3 more than seeing server 1, which is the case. So we go 2, 3, 2, 3, 2, 3, 2, 3, almost 10 times until we come back to server 1, which is the case. So now we see that the pool level ratio is taking effect, the pool member level. If we go to statistics, yeah, so it shows clearly server 2 and 3 are getting more connections. Let's go back to the pool and let's make it node, ratio node. Click update. Now we expect the other ratio. We expect node 1 to get 10 times than node 2 and 3. Let's see the results. Refresh. We see node 1 is getting more now. So yeah, clearly node 1 now is getting more connections because it is not the ratio as pool member, no, it is the ratio as a node, because node 1 has got a ratio of 10. So yeah, we can use the pool member ratio, we can use the node level ratio to achieve the same results. But one consideration I want to draw your attention, one use case. So let's say we have pool 1 and pool 2. Now, if I have node 1, node 2, node 3, I have here node 3 and node 4. So node 3 is a shared server between two pools. You think about it, one server hosting two different applications. One application served by pool 1, another application served by pool 2. Now, on the pool member level, I can say ratio 1, ratio 3, ratio 3. Ratio 1, ratio 3. This is on the pool level. So if I have 700 users going to application 1, this is going to be 100, 300, 300. If I have, for example, 400 users going to application 2, this is going to be 100 and 300. This is how it is on the pool level. But if we have our ratio configured on the node level and we want to achieve the same, so on node 1 we configure the ratio 1, on node 2 ratio 3, and node 3 ratio 3. So looking at this, we are going to still achieve the same results for pool 1. 700, it will be 300 connection, 300 connection, 100 connection. But remember that node 3 is also here, so the ratio is 3. If you configure node 4 ratio equal 3, then they will have equal number of connections. They will have 200, 200. If you want to still achieve the same results, you have to configure node 4 ratio equal 9. This will give you back 300 to 100. So this is a use case where when you use the node level and the node is shared between multiple pools, you have to take this into consideration. The last load balancing method we have as static load balancing is the ratio session, the one that we can select for pool. Ratio session, so first session means transaction. So it's different than connection. So we're not talking about connection here, ratio connection. We're talking about ratio session, which is a transaction, which is a session inside connection. So from user to server, we may have one connection, but inside that connection, we are doing multiple sessions. It's like when you open multiple browser tabs going to the same server, going to the same application. So you have one connection, but you have multiple sessions, multiple transactions. So the ratio session will take this into consideration. It will not take the number of connections, because maybe user 1 is opening one connection to server 1, user 2 one connection to server 2, user 3 one connection to server 3, but user 1 inside this connection has maybe 10 transactions going on. So when we get user 4 will not go to server 1. No, it will go to server 2 or server 3, depending on the ratio that we have. So it all goes back to the ratio you configured on the pool member. This particular load balancing method require layer 7 and layer 4 profiles to be assigned to the virtual server. We will see how to assign the profiles in a different section. But keep in mind, if you want to use the session based ratio, you have to have layer 7 and layer 4 profile attached to the or assigned to the virtual server.